comes to the graph, we're going to look at this graph. First thing, I'm going to choose some values of x. We're going to see in a minute why I chose them. So here, let me replace the value of x in the function, in the value here. So I'm going to look at the square root of 3 minus 3. Right, I replace the value of x with 3. I have the square root of 0, which gives me 0. That gives me the point 3, 0. Right? X was 3 to begin with. We just found that y is 0 as well. Now, if x equals 4, I have 4 minus 3 inside the radical. So that gives me radical 1. The square root of 1 is 1. So that gives me the point 4, 1. Now, if x equals 7, on the inside of the radical, I have 7 minus 3, which is the square root of 4. But the square root of 4 is 2. So that gives me the point 7, 2. The values of x that we chose were such that it was going to give me a perfect square. So it's not just random x's. I want them to give me random perfect square. Now, if I count by ones, I'm not going to be able to plug in my last point. So let me count by twos. So the 0.30, keep in mind each square I'm counting by twos. The 0.30, it's right there. The 0.41, it's right there. The 0.72, once again, I'm counting each square by twos. So it gives me that. Rough idea is when we're looking at the graph of a square root, my graph will look like that. It might be shifted to the side, it might be shifted up and down, but whenever we're dealing with square roots, it's going to look like that. Now let's talk about cube roots. Now, if x equals negative 8, let me substitute it on the equation, and I'm going to have the cube root of negative 8 plus 2. I know the cube root of negative 8 is negative 2. And negative 2 plus 2 gives me 0. So that gives me the point negative 8, 0. Now, what if x equals negative 1? I have the cube root of negative 1 plus 2. I know the cube root of negative 1 is negative 1. And negative 1 plus 2 is 1. So that gives me the point negative 1, 1. Now, if x equals 0, that gives me the cube root of 0 plus 2, which is 0 plus 2, better known as 2. So that gives me the point 0, 2. Now, if x equals 1, I have the cube root of 1 plus 2, which is 1 plus 2, better known as 3. So that gives me the point 1, 3. Lastly, if x equals 8, that gives me the cube root of 8 plus 2. I know the cube root of 8 is 2, and 2 plus 2 is 4. So that gives me the point 8, 4. All right, let me put these points in. Once again, I'm going to be counting by twos in order for me to be able to fit all my points. So the point negative 8, 0, it's right here. Once again, I was counting by twos. Negative 1, 1, it's spot right here. The point 0, 2, it's here. The point 1, 3, and the point 8, 4. Now, cube roots, part of it looks like a square root. You guys can see how the square looks like. The other half looks like a square root upside down. So rough idea, cube roots are going to look like that. Once again, it could be shifted up and down, sideways, but that's how it's going to look like. All right, now let's move on from the graphs. Find each square root that is a real number. The square root of 7 squared, we can do this the long way. I can say the square root of 49, because I did 7 squared, the square root of 49 is 7. So 7. That's the long way. Now, the short way is the square root and the squared cancel each other out, and I get the number in the inside. Now, on B, it is kind of tricky though, because if I do the square first, negative 7 squared, that gives me square root of 49. Notice how the squared did the positive value on the inside. It converted the negative 7 to a positive 49. So I'm going to get 7. The squared and the square root are going to cancel out, but because my exponent is an even number, it's going to convert the value on the inside positive. So looking at my example C, the square root of k squared is k. But the square root of negative k squared, so the squared and the square root are going to cancel out, but before I cancel them out, I'm going to make the answer on the inside positive. So my answer for D will also be k. Here, to simplify each square root, the squared and the square root are the same thing. So they're going to cancel each other out. But because my exponent is an even number, make the inside positive. So my answer here will be 3. For example B, the fifth root and 5 are going to cancel out. Because my exponent is an odd number, do not make the inside positive. I'm just going to say my answer here it is negative 4. Here, these things are going to cancel out. The fourth root and the fourth power going to cancel out. Because my fourth is an even number, we're going to make the inside positive. However, because of the negative sign on the outside, my answer will be negative 9. Here, technically, I have a 2 up here. Now, m to the fourth, I can rewrite this as, let me have the negative on the outside. I have the square root of m squared, that's m to the fourth. That way, the square root and the square cancel each other out. So I'm going to have m squared. Because of the negative sign on the outside, my answer will be negative m squared. Now, example A, I have the cube root of a to the fourth to the third. I want the cube root and the cubes powered to cancel each other out. So my answer will be a to the fourth. For example F, I have the fourth root of x to the third to the fourth. So the fourth root and the fourth power cancel each other out, and I get x to the third. Now, some of you might have seen a shortcut. When we're dealing with letters, we're going to go the power divided by the root, 12 divided by 3. If I'm looking at F, the power, 12 divided by 4. If you go back to D, the power, 4 divided by the root. Now, verify things and use a calculator to deal with these. Basically, what we want in this section, know how to do square roots. We want you to practice cube roots. So we're giving you the answers so you know what each of them are, because on your homework, you will have to be dealing with some of them. It is just for you to practice how to use a calculator when the root is not a square. You might have a key that have this key. That's how you're going to use the non-square roots. Some of the keys on your calculator might have an X. So it's just for you to practice using your calculator.